let me introduce myself. My name is Nivita Khole and I'm working as a technical support engineer in Midas. Welcome to the webinar on Midas Engine Software Solution, an all-in-one solution for structural design of buildings and general structures. In today's webinar, we are going to look at company introduction to Midas Engine software, its strengths, what kind of Midas support services are included. We'll have a conclusion regarding Midas engine. Midas was established in the year 1989 by Fosco Group, and since then, Midas software solutions are distributed in more than 120 countries. All right, so let's come back to Midas engine. So Midas software solutions have been sold from 2003, and from 2003 we have got a lot of users worldwide. So the software is a developing software company. The company is developing, so there are more software solutions and updates every year, every 6 months, and we are getting support of many users worldwide. Midas is known to be the biggest CAE software developer in the field of civil engineering, as there are 4 main family programs. One is in bridges, which has Midas Civil and Midas FEA software solutions. And Midas Civil basically can perform the analysis and design of simple, conventional bridges like box culverts, slab bridges, frame bridges, to little advanced types of bridges like composite bridges, steel composite or PSC composite bridges, box girder bridges, and also the high-end bridges like suspension bridges, extra doors bridges, and cable stayed bridges. Midas FEA is our advanced nonlinear and detailed analysis system. You can perform impact analysis, or you can perform nonlinear total strain crack analysis, and so on, or even contact analysis. Then coming to the structures family programs, there is Midas Engine, which is an integrated system for buildings and general structures. Midas Drawing, that can take out drawings out of the designs generated from Midas Engine and also generate bill of material. Midas Design Plus is our structural component and design and detailing tool. Coming to the geotechnical, we have 2 softwares. One is the famous 3D GTS NX software solution, and we have 2D a finite element as well as analytical geotechnical solution, that is SoilWorks. Mechanical field has 2 software solutions, Midas NFX and Midas FX Plus. NFX can also be utilized for impact analysis and CFD analysis, which is usually an application for civil engineering works. Okay, so one important part is that all the Midas software solutions are integrated with each other. So the models from one software can be taken into other software. So if you're having a bridge or a building, you can export the model to our geotechnical software, wherein you can perform a complete or a direct soil structure interaction. Let's move ahead to the introduction to Midas Engine software solutions. Midas Engine is our next generation solution for building analysis and design. You no longer have to use a separate analysis or a separate design tool and separate drafting tool, because everything is included in Midas Engine itself. It's a one-stop solutions like drawing to drawing. You can import drawing architectural, and then you can generate the model, perform the analysis, perform the design, generate the reports, also the quantity takeoff, and finally provide a structural drawing as an output. So it's a drawing to drawing all-in-one design system. Let's look at its major strengths in the parts of integration, automation, optimization, and high quality. When it comes to integration, we can see that modeling, loading, analysis, design, and output, everything is integrated into one solution. Modeling becomes easy and fast as it has CAD-based modeling feature. Loading, we have got auto generation or specialized loadings like lateral loads, wind loads, and seismic loads. Analysis, we can perform multiple types of analysis in a single model file. Optimal design, we can optimize the structure by considering the rigid zones. We can get the auto generation of the output in the form of drawings, Word file, or Excel sheets. We get the quantity takeoff in the form of Excel sheet, report in the form of Word file, and drawings in the form of DWG files. Let's look at automation in a part of modeling. We have tracing type of option that can help to automatically define the different section properties of columns and thickness of shear walls. We can also trace the location of beams using the center line. We can manually also draw using CAD-based features. We can trace the periphery of the slabs and generate the slabs. Whichever slabs we don't want, we can just simply select and press delete from our keyboard. So that's a tracing feature, a CAD tracing feature in Midas engine. There are some more CAD features for editing purpose like move, copy, stretch, extend, trim, and we can generate any shape of opening. We can also create general type of shape because Midas engine is also capable of performing and has also the capability of performing analysis of general structures. So you can have very easy modeling. Good part is that you can have mesh of any size, and that meshing can also be modified easily by simply going to the settings. So there is basically auto meshing feature, which is during the analysis, not before the analysis. Another good part is that Midas engine has all types of foundations, the strip footing, isolated footing, mat footing. When it comes to plinth beams, you can model them as footing girder, pedestals below the steel columns, pardon me, steel columns. And we can also include basement walls and apply earth pressure on the basement walls. So that's about the automated foundation systems that we can model. Apart from that, we can include our pile arrangement or pile supports below our mat foundation, or you can call it as a pile cap in that case. So that's about different automations in the modeling in Midas engine software solution. Now, before I go ahead with automation in the loading, let me show how we can model the structure in Midas engine. So I'll directly start with the demonstration. This is going to be the final model, and this is our new file right now. We can have multiple models open in the same window. There is unit system at the bottom, which can be modified at any point of time. There are some options which are similar to AutoCAD at the bottom, like snapping tool, intersection, orthogonals, snapping parallel, and so on, constraints and so on. So that's about the easy access features. Then we have ribbon menu at the top. From left to right, we can finish with the modeling, loading, boundary conditions, analysis, design, results, reports, and drawings. We have tree menu, model tree menu, analysis tree menu, design, display, and table tree menu. Easy to access information regarding the model. We have properties menu box, which gives information regarding a selected member. Okay, so that's about the user interface of Midas Engine. One more thing is that the workspace is divided into three modes, 3D, plain, and story mode, to make the modeling much easier. When it comes to generating or creating a model, we have different options depending on the type of project. We have got import function wherein you can import the Tekla files, convert them into MGT file and import it here. We have integration with GTS, NX, our geotechnical software solution. Stat files, parasolid files, DWG, be it 2D or 3D, DXF files can be imported. That's one method of modeling. The other method of modeling is using the tracing feature, which we saw the video of in our presentation. We can trace the location of columns, shear walls, beams. Then further, we have got grid line. So there is a 3D grid line option available, which can be also converted into member, very easy feature. Then we have got CAD-based modeling tool. So if you're using coordinates system, then you can directly start creating your members using the coordinates. Lastly, we have body type of feature for modeling, as in you can sketch your entire structure and choose parts of it to be converted into members. So that's about different method of modeling in Midas Engine. In today's session, I'll be showing about our 3D grid line. This is our 3D grid line basically, and we can actually choose the X direction, Y direction levels as well for our grid line. So for example, I am having, let's say, 6 numbers in the X direction, and in the Y direction, I've got some 7 numbers of base, and we can have even different uh, information for the spacing between each bay. So let's say this is of 6 meters. So like this, we can provide information. Okay, and levels, we can also provide levels and the height for each level. So I'm providing, let's say there are 10 floors of 4 meters height. So I can just click on apply and press escape to come out of the command, similar to AutoCAD. All right, so here we have got this information. Now, if we would like to modify this grid line, we can do it easily. We have some options here like dimensions, wherein you can actually select the dimension for the grid lines, and they can be modified. So you can actually change the size. For example, let's say over here you don't want 6 meters, you can change it to, let's say, 3 meters, press enter, and the grid line is modified. So it's that easy. Same thing over here, 3 meters, likewise. Okay, and press escape. So very easy to edit the grid line as well by simply changing the numbers from the display. Another thing is about converting our grid lines into members. So you can actually select the type of member you want to generate and the section property. So by default, there are some section properties already generated in Midas engine. Even the material properties are predefined. Those can be modified or you can add some more. So here I'm going to be modifying the grade of concrete. It's by default as per European standard. We can change it to American standard. So I'm using C4000 here, and I'll click on OK. The section properties are also given over here. These also can be modified. There are some thickness properties also which can be modified, or you can add some more thickness properties. For example, I would like to add the thickness for the mat foundation as 0.5, and I click on OK. So it's there. Very easy and handy tool. Now I'll use my convert into member option to select the section size of 400 by 600, and I will simply just make a selection for all the beam members, horizontal grid lines, and I'll click on apply. So we can see over here all the beams are generated. Then further we can also create columns in the similar way. I'll use section property as 500 by 500 and select the entire floor plan. Apply. Okay, so we have got our beams and our columns. I can press escape to come out of the command. And let's also make some shear walls. So I'm going to make shear wall at this location, and that's why actually I reduce the size. So I'll again press spacebar to come back to the same command. So if you are into modeling and all, you can understand how easy it can get if we have the same features as AutoCAD, like spacebar to come back to the same command. So wall, here we have got wall. I'll change the thickness to, let's say, 300. And we have different types of analysis for wall. Now, wall will be definitely designed as a shear wall in Midas engine. But when it comes to the analysis, there are different methods. So we have wall membrane, plate not meshed, which is a shear wall made up of rigid beam at the top and bottom connected by a long column. And then there is wall plate meshed, which is a plate element itself, which will be meshed by the program while analyzing. Okay, so here I'm going to be using wall plate meshed, and we will just simply select the periphery of the shear wall. So I've just selected this periphery right over here, and we can also look at the preview of our shear wall, which is going to get generated. And then I click on OK. So I've got my shear wall modeled. Now I do not want the beams and columns surrounding it, so I can actually choose to delete only my beams and columns by making a selection filter. So I'm just going to be selecting beams and columns in these locations and simply press delete from the keyboard. So here we go. We have got our shear wall as well. Okay, now let's get to generating the slabs. So we can go to the member, go for slab option, and we can select all the periphery beams. So here I am going to use 150 thickness for the slab, and I'll use slab plate out in, as in it will take the in plane as well as out of plane stiffness. If you want to take only the in plane stiffness, then slab membrane should be used. Okay, and then I'm just going to select all the beams. The program will automatically detect the periphery and then only create the slab members. We can also generate these slabs using the periphery grid lines. So that option is also available. Okay. After this, we can just click on apply. Basically, the program shows us a preview, and then we can go ahead, click on apply to if you're okay with whatever is going to get modeled. Okay, so our slabs are there with us. While performing the analysis, the program will automatically do the meshing of these slabs. Now, the locations where we do not want the slabs, we can just simply select and delete those locations, or we can even create the openings. So these are certain options available. So if I go for the line over here, I create the periphery of my opening. So let me go to this plane view and can go for a line. For example, I'm creating so basically we can either create lines or we can even select the periphery. So here I'm going to go for the member opening, and I can do the selection, and I can say apply. Let me go for basic so that it's properly selected. Okay. Ah, 2D. Okay, and then press delete from here. All right. So we are done with creating the openings as well, wherein the shear wall was placed in between. Now, if there are any further modifications, we can do that. For example, if you want to make an irregular floor plan, you can just delete some parts of it. For example, I'll just delete this much portion, and you can make it L shape or any other T shape, maybe perhaps like this. So I'm just making it an irregular plan. All right. And further, you can simply go ahead with generating the stories for it. Now for generating the stories, you can go to the structures and story data and add this information, and you can even auto-generate the story data. No need to manually provide the information. Just select the members and click on OK. The program will automatically detect the height. The height can be modified from here. The floor-to-floor heights of each floor can be modified from here. Now we do not need the grid lines anymore, so I'll just hide the grid lines. And we can go to any story using this story mode to do any modification. For example, I would like to add my mat foundation on the lower level. So I can go to the story and 1F level, and I can go ahead to add the member for my walls, for my footing. So I'll just click on the periphery. I'm sure I need some offset. So for that offset, I can provide a distance here of, let's say, 1.5 meters and press enter. So I've got my mat foundation with offsets. I can also include pile. Now piles over here cannot be designed. These are only to apply the spring support to our pile cap. So I'll go ahead with definition of a spring set here and pile springs. So we have a database of Korean standard and Japanese standard, so you can use if you want, but I'm not going to use that. And I'll keep the information for the pile as it is right now and use the pile bearing capacity information. So let's say each pile has the capacity to bear 1000 kilonewton of compression and 100 kilonewton of uplift. And then the spring constants I can provide over here. For example, I'm providing 1000 in the X and Y direction and 10,000. These are just arbitrary values. Of course, the actual values would be different. Okay, so I provided the spring set and pile spring information. And now let's say I want to apply the piles just below these columns. So I have various options to generate these piles. I can do it by point, I can do it by line, area, and so on. So I'm going to be selecting point, and I'll have the selection tool to select all the locations right below the columns. Okay, so this is selected right now, and I'll click on apply. We can also change the number over here of piles. So let's say below each column you would like to have two numbers. So you can write 2, and as you can see, there will be two numbers of piles below each column. So I'm making 1 for now, and I'll click on apply. So modeling these pile supports is actually very easy. I'm pressing escape, and then we just simply click on pile array apply. So we have got our piles just below our entire structure. So after this information is completed, we can simply go ahead to the next part of modeling. Well, we can also choose basement walls. So if you want basement wall, there is basement wall option as well available. Well, we can go to the T1F and you can model the basement walls by using reference lines or by using biselect parallel lines and so on. So there are different options available. Okay, so you can choose basement wall here, and then you can click, sorry, on 2 points. And you can just make the basement wall in this way. So easily create the basement wall. Modeling actually becomes very much easy in Midas engine software for all the types of members. Okay, so this is, oh, I missed that other part. Anyway, so basically this is how we can do the modeling of the basement. And I'll get back to the 3D mode now. We have our entire structure. So let me also see, I think I've provided incorrect thickness for the basement walls. I'll select the basement wall and I can modify the thickness from this properties menu. So I made it 300 and that's it. So easy modification of the properties for any member can be done over here as well. All right. After this, we can move ahead to the next part, that is loading. In the loading, there is sulfate command. So you just have to click on sulfate. The set, that is a static load set, is nothing but our load case. Why is it called set? Because it's also like a group which can be activated or deactivated in an analysis case. Okay, so we have one sulfate applied, and then we can apply point loads, beam loads, pressure loads, temperature load, settlement, and arbitrary loads. Arbitrary loads would require just creating some faces on the floor, and then you can apply any pressure load on it, or line load wherever the lines are created, or point load wherever required on the slab. Now, when it comes to slab, be it a slab, simple type of a slab or a flat slab, you can also assign slab load by using types option. You can include your dead loads as well as live loads in the same type. You can create as many number of types as you want. So here I'm creating a typical slab load type with live dead load, I mean floor finish of 1.5 and live load of 2.5. These are arbitrary values, of course, it would differ with your projects. And then further, okay, let me save this model file. Okay, and we'll move ahead to apply the slab load which we had just defined. So here all I have to do is simply select all these slabs and then click on OK. So the slab load is applied to all these slabs. Okay, so after this is done, we can move ahead to the next part, which is the application of the wind loads or static seismic loads or response spectrum loading, earth pressure, and so on. So when it comes to wind loads, we have got assign wind load function, which is applicable for enclosed area, open area, equipment type, or story-based type. So as we have this building structure, I'm going to use story-based type, and we will get the wind loads automatically calculated as per AC 710 or AC 705 or even IBC 2012 or 2009. So these standards are available for automatic calculation of wind forces on the structure. The program will automatically take the average roof height, and then comes the gust factor or pressure coefficient, which can be automatically calculated by the program if it is rigid or if it is flexible. So if it's rigid, the gust factor is auto-calculated. You can also manually provide the gust factor. You can choose to have the minimum design wind loading as 10 PSF. And you can also generate a report in the form of Word file. It gives information about how the calculations are done. Only the external pressure will be considered here. And it is going to be windward and leeward, orthogonal in the direction, windward and leeward direction. So you get all this information in the Word file format itself. and you can click on OK and then use it for the structure. You can even look at the forces applied before performing the analysis. Okay, so after this is done, we can go ahead to static seismic load. And again, the static seismic load can be automatically calculated as per UBC or IBC or AAC 705 or 10. So if you're using UBC 97, you can select the soil profile. You can select the seismic zone, 2A, 2B, whatever, and then importance factor, and also yeah, approximate period, which can be calculated automatically as per the selected, as per the required formula. So you can simply press on calculate and the calculations would be done. You can also manually provide the value of the approximate period. The ductility factor can also be modified over here. For example, 5, and then click on OK, close. You can apply the seismic load in both X and Y direction at the same time using generate load set for ortho and providing a scale factor for the orthogonal direction. You can look at the profile of the base shear. So this is the base shear even before performing the analysis. Okay, and you can click on OK and OK so that the seismic load is applied. Now, when it comes to seismic loads, you also need to perform the loads to mass command, as in you need to convert your 100% dead loads and 25 to 50% of the live loads. So I'm converting 25% of the live loads into masses, and that's it. So the masses are also automatically calculated by the program. All right, so that was about the loading part, wherein we saw how the lateral loads, that is wind and static seismic, can be applied. Now, if you're using the wind tunnel test loads, then you can actually go to the show profile over here and apply additional loads for each story set and stories separately. Okay, so that's how you can, I mean, there is an Excel copy paste option as well to do this very easily. That's about wind tunnel test results that we can apply. Okay, so that was about the automation in the loading part, wherein we saw that the wind loads can be applied on building structures, can be applied on enclosed open structures, and we can also apply on equipment-based structures by converting the forces from reactions. Okay, now here we are having automation for the seismic load as well. Static seismic we saw, but there is also response spectrum. And now let's come to the optimization, wherein shape offset can also be automatically applied by the program. So for that, we can actually go to member and we say generate, wherein the program will detect, I mean, for that we need to basically select the entire structure. So I'm selecting everything and I'll click on apply, and the offsets will be generated by the program, as well as the rigid zones. One good part is about aligning as well. We have this align section option, wherein you can actually select your beam and select the plane and then assign it or flush it to the required plane. For example, flushing it to this column. So this is how easily we can create the offset to the beams. So it's an easy feature. I've undone it. And next part in the loading is about earth pressure. So in the earth pressure, we have earth pressure function, wherein you can specify what is the ground level. So let's say 4 meters for our structure is the ground level. The water level is, let's say, at 1 meter height, and the bottom level is 0. Soil density is 18 kilonewton per meter cube, and internal angle of friction is, let's say, 30 degrees. And if there is any additional load on ground, you can add that as well. For example, 5 kilonewton per meter square. And then click on calculate. The triangular and trapezoidal loads will be automatically calculated by the program. Now, once this earth pressure function has been auto-calculated, you can just simply select the basement walls and apply the earth pressure function on them. So I'll select these basement walls and I'll just say show only. And it's better, basically easy to do this option. We can also apply to plate type of shear walls, but I'll be applying it only to the basement wall. So I select this basement wall, I click on add. The earth pressure is going to get applied from outside, so it's correct from here. I can select this, click on add, so it's correct. So we can actually add one by one to understand if any part is to be reversed. So we can reverse this and again add over here. There is, I think reverse would be required for this as well. So modify. Okay, reverse this. Okay, I think this one also requires reverse, and so would this. Okay, so we have applied the earth pressure loading. We can apply the earth pressure loading in this way. And we can also consider the buoyancy at the bottom. So you can actually select the plates for the buoyancy. So there is buoyancy bottom. You can select and you can just click on OK. So in this way, triangular trapezoidal earth pressure loading, buoyancy loading is applied to the basement wall and the mat foundation. All right, so this is one part. Next, we'll go ahead to the boundary conditions now. In the boundary conditions, there are supports that we can apply to, like the fixed supports and the pinned supports. These can be applied to the structure. Okay, so that's about the support conditions, fixed, pinned, or user defined. And beam end releases, plate end releases options are there. Then there are soil supports that you can include for simulating the soil structure interaction, approximate type of soil structure interaction. There is area type of distributed spring supports as well that can be applied to the face of our mat foundation. So if you want, you can include this information as well. Wherein the modulus of subgrade reaction is supposed to be applied. So let's say 20,000 kilonewton per meter cube. Okay, and if you if you do not want to allow any lateral displacement, you can even constrain its points, end points, or all the points by using point spring support or even using the simple support. Okay, so if I go for properties, I can actually have a high stiffness for my X and Y direction just to constrain my X and Y direction for my foundation. So this I can simply select the corner points. I'll go from the top view and do the selection. So I can just do the selection of these corner points in this way, and I'll click on OK. So I've applied the constraints in the X and Y direction at these corner points. It actually depends on your practice. If it is different, you can do it in a different method. Okay, so that's one part. Then coming to the diaphragms. So diaphragms can be assigned manually as well. So simply select over here the locations where you want to apply the diaphragm and click on OK. The diaphragms also have been applied to the structure. Coming to the rigid region. Now, uh, when we have got flat slabs or mat foundations, we don't want the line elements to pierce the or to have high stresses at the connection between the mat foundation and the columns. So we have got the bottom column section shape with automatic rigid links. So I'm going to be constraining completely, making a rigid zone between the column and the mat foundation. I'll select all my columns over here in this way, and I'll click on OK. And after this is completed, I can simply go ahead and say auto generate so that all my rigid links or my rigid zones basically will be activated, and also the offsets will be considered for the analysis purpose. So this is done. One last thing, I have to also do the modification of the thickness of my mat foundation. It's T500. So now it's complete. One more thing, I want the program to consider the basement, or the ground level at 4 meters. So I'll have to go to the story and change my control data to 4 meters. I can also choose the options like consider mass below ground level and I can also have inherent eccentricity applied or calculated by the program. Okay, so there are various options available in Midas engine. We are done with the modeling, the loading, and the boundary conditions. Now we can go ahead to perform the analysis. Okay, so here we can basically start the analysis settings wherein the mesh size can be controlled. You can also have separate mesh size control on members, separate members. And you can also choose your number of processors for speeding up the analysis. You can generate the load combinations for steel and concrete separately as per American standard. So here I'm going to change the code to American standards, and we can also choose what kind of rebar we would like it to use. So if you're using ASTM or BSEN, any type of grade of steel reinforcement can be utilized. And further, there is some checking controls option available. For example, member forces for our mat foundation and for our slab. So you can actually choose if you want the results for element center, nodal results, or nodal average results. And the average design for wood armor moments. Wood armor moments basically would consider flexural and torsional moments. And for that as well, you can have the average design forces included for the design purpose. So these are various options available in Midas engine. All right, so I've used ACI standard to generate automatically the load combinations. So strength as well as serviceability load combinations would automatically be generated. So I'll close this and then we can move ahead for the analysis. Now you can have as many number of analysis cases as you want for one single model file, which means that you can have, let's say, the entire structure with a fixed support condition and one entire structure, or this entire structure with pinned support condition. With foundation, without foundation, you can choose. For example, here you can actually uncheck basement, and your basement foundation elements will members will not get considered for the design, sorry, for the analysis. And you can also choose from here the support condition for the design analysis purpose. Without the analysis, the design won't take place. So of course, for design as well. Okay, so I've chosen everything, and we can click on apply. We can also perform the analysis without the lateral load. So these options are also available. Okay, so for quick analysis, I'm not including the lateral loads so that the analysis will be quite quick. And further, apart from that, we have got modal analysis. That means eigenvalue analysis, buckling analysis, and crane load analysis, which is a moving load analysis itself, which is applicable for steel structures. We'll see that tomorrow. And when it comes to flat slabs, we can also perform cracked section analysis after assigning the reinforcement to the flat slabs. Okay, so that's one part. Now let's go ahead and run the analysis. We can choose which analysis which we want to perform for the design purpose. And I'll go ahead and perform the analysis number 2. This is only to reduce the time for analysis, as there are many members here, and the meshing is also going to take place for all the elements. Okay, so by the time the analysis is taking place, let me get back to the presentation and let you know that in Midas engine, when we had the tracing modeling option, that time also you can choose the offset while tracing. Okay, so for example, you have got the center line of your beams. Okay, and also you have got the shape of your columns. So if this is the second picture which I'm encircling right now, if this is how your tracing file is, then this offset for each column will be automatically assigned by the program. So again, that's an automatic automation that can be very much useful for making the structure more practical. Okay, so that's one thing. Next thing I would like to talk about is the wall columns and the plate beams. So when you have got long walls, let's say 1 meter, 2 meter long walls, then those are better to be analyzed as elements. Okay, so we have that option, wall column option, wherein the program will perform the analysis as meshed plate elements, but the design of these walls will be as as a column. Okay, so you'll get the column design out of the wall. Then we have plate beams similarly, wherein you can use it for deep beams or for assigning the drop slabs. So in this case, you have got again plate elements for the analysis, but the design will take place as a beam member. Okay, so that's also an optimization. What all codes do we have for the design purpose? So we have got American Standard, European, British, and Korean Standard in Midas engine for steel and RC design. And we will finally generate the high quality outputs. We have seen one type of output, which is the word file output regarding the loads that have been applied, the lateral loads. Okay, the analysis is completed. Now let's look at the results. The analysis results can be easily seen by just expanding the analysis results from the tree menu and double clicking on it. Let me undisplay or hide all the information labels. So I'll just hide all this information. Okay. All right. So we have got our analyzed structure. You can deform it. So this is the deformed shape. You can see the legend over here. You can change the unit system at any point of time. And you can go to any load combination from here as well. So let's say for the serviceability condition, we have 15.78 as the displacement. That's in mm. Okay, you can also display the value on the screen so you can see easily what is the maximum value and where it is. Then we'll go ahead to the results like the reactions. Well, when it comes to mat foundations, we need to check with the subgrade stresses. So the pressure, vertical pressure for our subgrade would also be applicable here. I think it has not been used for, okay, it's available here. All right. So we have got the plate stresses and so on available here. So von Mises stresses at the top and at the bottom also can be seen separately. And shear stress at the top and bottom can be seen separately. Okay, you can actually activate only the mat foundation and you can see separately for that. Okay. So care has been taken that the rigid zone is maintained. Okay, so that's about the pressure, stresses in the mat foundation. Okay, this subgrade stresses would be applicable when we have applied the boundary condition of soil support. Okay, so that's one part. Next is about the beam forces. So if I go for beam forces, bending moment diagrams, we can see those information. We can even go to story by story. I'll go to, let's say, 6F level, for example. So as the beams are divided into number of parts because of the meshed slab, we are able to see spikes here, but of course we can see a smooth level as well if we want in the results part. So that's about one thing. This is by model, this is by element, and this is by member. So you can see the values for the absolute max. Just change the unit system to meter, kilonewton meter. Okay. So yeah, that is it. I'll just do undeformed shape. All right. One more thing I would like to show is about the forces. So let me show the plates and let's say the bending MXX. So you can see here the MXX values, and you can also have an on curve diagram. You can click on 2 points and create the on curve, and you can get to see the values on the screen for any information. Okay, so that's about the on curve diagram. And then further we have got different types of options, like there is a tag option. You can actually click on a particular element and look at the results over here, the values over here. All right, so that's about the results in the display form. You can also get the results in the form of tables. So for example, you can get to know the information of nodes and elements in the form of table, and the deformations as well. So you can select the nodes for which you want to check the results, the reaction displacement results. The reactions also you can check applied forces, beams, for the beams, forces and stresses, plate forces, stresses, the boundaries, and if there are any virtual walls, subgrade reactions, subgrade strains, you can actually use the tabular information. Okay, so that's about the tabular results that can be taken out as an output. Now we'll go to the design part. In the design, again, we have got different standards available that we already saw. Combination already created. Design groups can be automatically generated for the entire structure. So I'll just click on OK, and the groups would be generated for all the members automatically. So even though we have activated the entire structure or not, the groups would be generated. I'll just initialize the entire structure so that we can see the groups. Okay, so there are groups over here based on each story and the section size, section shape. Okay, and further we can go ahead back to the design tab, and then there are member parameters which can be assigned to separate members. We can define the rebars to our plate elements, or like the basement wall or the mat foundation or even our slabs. So here I'm going to create one design case using the analysis for design 2, and you can see here all types of groups are there, and I'll just click on OK, and then I'll go to the design case, sorry, run design. And I can also have the rebars automatically generated by the program. I can have complete control on the design. So depending on the section depth over here, for example, I have got 0.6 as my section depth. I can choose that, let's say P16 is my minimum diameter of bar that the program shall use. Number of layers, well, 2 number of maximum layers it can use. We can change to 3 numbers at the max. And then the shear rebars, the spacing for the shear rebars can be controlled, and so on. Similarly, for the plate elements, you can, sorry, wall elements, you can choose. And let's say P13 is not the maximum rebar for the walls. I'll go to the RC, sorry, rebar, and I can change the or add the number of diameters of bars that the program is allowed to select. So here now in the walls, maximum I can select P20, 25, likewise for the design of shear walls. And same thing is applicable for the basement walls. So I can select likewise for the mat foundation. Also I can select, and then I'll click on OK. And then we can go ahead to perform the design of all the members included in that design case. So we can actually have multiple design cases for a single model file. You can choose, let's say you want to perform design for only the mat function or only the basement wall. So likewise, you can choose only those groups, and you can perform the design for group, those members in the group that we have selected. So that will also reduce the time required for this. Right, by the time the design is taking place, let me look at some questions. A question is regarding optimal design for steel structure only. We will soon be having it incorporated in the program. Midas engine currently does not have optimal design for steel. Next question was if we can have design of waffle or rib slabs or solid and flat elements only. So yes, we can perform the design for waffle and rib slabs and solid slabs and flat slabs as well. So these options are available. However, the process is simple. You just have to draw the ribs along with the plate elements. So it will the ribbed slab or the waffle slab would require to include the ribs and yeah, basically the line elements to make the waffle. Okay, then another question was, can we design piles for pile foundations? No, we cannot design piles in Midas engine. We can decide how many numbers of piles, as in we get the information about what is the capacity of the pile. So that capacity information we can provide over here, and we can draw the pile arrangement, or we can choose what should be the pile arrangement. Again, that would be with the help of iterations, iterative design process by which will tell us what should be the location of the piles, or how many number of piles would be required, configuration of piles basically. A question is about IFC file. Can we import IFC file? No, we cannot import IFC file as of yet. We already we earlier we had Midas Gen program, which has some advanced features, and it is based on node element type of modeling. So the main difference between our older software Midas Gen and the latest software, that is Midas Engine, is that the modeling method, Gen is node element based modeling, and Engine is member based modeling. Next is regarding some design conditions that the program is capable of providing in addition, which we will see after the design has been completed. And one more thing is that, of course, Gen has got more high capabilities, like pre-stressing is there in Midas Gen program, and construction stages and heat of hydration analysis. These all things are there in Midas Gen, which is not yet included in Midas Engine. Engine is going to be the future. It will be replacing Gen in near future, but that will take a long time. But if you're interested into advanced analysis, Midas Gen is the right solution. Another question is, can we analyze pile only? So I suppose that is without the mat foundation. So yeah, we can apply the piles without the mat foundation, no problem. Another question is, why to constrain X and Y direction? If you have seismic load, well, it's not a compulsion, of course. It's just for quick analysis that I provided over here. Another question is, if the center line of beam and column does not coincide, the program will take the effect of eccentricity. Yes, yes, that is right. The program will take the effect of eccentricity if the center line of the beam and column does not coincide. That is correct. Basically, it will provide an offset to the column, which will make the eccentric loading. Another question is about Indian Standard Code. Indian Standard Code is not included in Midas engine yet. Punching shear check has to be checked in the design process itself. So it's not a part of analysis, but a part of design. We need the reinforcements for the punching check as well. If we don't have the reinforcement, we can still get the punching check, but still, practically speaking, we do have reinforcements which can be considered for the punching check. Now the question is, in the design, does program consider maximum load combination? Yes, load combinations after they are generated while designing the program will definitely take the maximum results, the critical design forces for the design purpose. Can you design due to torsion stress? Yes, torsion also can be considered. When it comes to mat foundations, wood armor moments would take the effect of flexural and torsional forces or stresses. And yeah, so torsion stress is also available. Also, when it comes to frame elements, for them as well, torsion design is available. Okay, now the question was regarding the bending moment diagram, why it was so spiky. So basically it was because the beam was divided into number of parts, as the meshing of those plate elements was automatically done by the program. So as there were forces coming on these beams due to the mesh or divided elements, basically the program automatically divides the beam into number of elements, small elements, because of the meshing. And as the load from the plate elements was coming irregularly on these, or as point loads on these beams, the bending moment diagram was looking a little spiky. Okay, we are done with 97%. Okay, another question is about generating 12 wind load cases according to ASC 7. This is not yet included in Midas engine. We can, however, put it as a development request. In Midas engine, you'll have to create those same 6 times. Like those 12 wind load cases you can create by using the option 6 times, because each time you can make it in orthogonal direction. That's why. Pile distribution regularly below raft, not below each column only. I think you mean to ask if we can have any other type of distribution below the mat foundation. Yes, of course, we can. I had just made it a simple type of application of pile loading, a pile support right below the columns, likewise. But we can have any other arrangement of pile supports. Optimization by changing the size of beams and columns is not applicable in Midas engine program yet. We would be definitely including it in the software. Midas engine provides story tables for irregularities like weak story check, soft story check, overturning check, and so on, stability check, and so on. Is post-tension design for slab available? Post-tension, pre-tension is not available in Midas engine. I would, if anybody is interested for ribbed slab analysis and design, I can share a video separately on that. So you can let me know over here in the questions box itself if that's of any interest. Pseudodynamic, well, we can perform response spectrum analysis, but dynamic like time history analysis and time history analysis cannot be performed in Midas engine. We have to use gen for that purpose. Soil structure interaction can be performed using Midas engine and GTS NX software solutions. You can take the entire structure from engine to GTS NX, perform the nonlinear analysis in GTS NX with the actual soil, and get the spring results, soil spring results from GTS NX to Midas engine software, so that the structural engineers would be able to perform the analysis and design of the members with the actual spring support. Live load pattern for slab design is not applicable in Midas engine. I can share with you the major difference between gen and engine software. We cannot have design of beams with openings in Midas engine software. We can, however, reduce the stiffness of the beams if required. Another question regarding soil structure interaction is about the pile reactions to another Midas module as in GTS NX and back to main program with iterations. I mean, that is the subsoil structure interactions process or indirect method of soil structure interaction. That is possible, the iterative method, it is possible, even the direct method is possible by getting the analysis results from Midas GTS NX itself. Can we perform the design for beam type of mat foundation? Yes, we can include beams. There is footing girder available. Okay, regarding the beam behavior, well, in many programs we have membrane type of slabs which does not affect the analysis of beams, and that's why you can see a nice graph or a normal bending moment diagram Same thing is available in Midas engine as well. If you use membrane type of slabs, then you'll get a smooth profile for beams. But this is a meshed plate that we are using over here for the analysis, and the mesh size is also pretty big. So because the mesh size is big, like it's 1 meter, so for a small slab of, let's say, 5 meters by 5 meters, there are only going to be five nodal point loads on the beam. If you apply nodal loads on the beam, you can check by yourself what would be the analysis result. Okay, so let me actually clarify all the doubts over here. I'll just open another file of Midas engine so that we can go ahead. So I'll open this model file. So as I said, this is how the meshing would take place, and accordingly the beam forces would be shown. All right. So let me go ahead to the part of design. Now, after the design is performed, we can actually get the results like this, like the total status, wherein you can actually see which members have passed or failed, or which members requires check. So mat foundation seems to be failing over here, but the basement walls are passing, and the rest of the members, like the columns, beams, and slabs, they are all passing within the specified limits. There is strength check separately, bending ratio check separately, then shear ratio. So shear ratio is pretty high, 3.58 for our mat foundation. Then there is serviceability check available, and we can also get the results in the form of detailed Word file report. So let me show you about one beam, one column, one slab, one shear wall, a basement wall, and a mat foundation. So after I click on OK, a Word file will be generated for the design, showing the design results of the selected members. So this is the Word file generated by the program. You can see the rebar arrangement, and we can see the formula and also the subclause numbers. Okay, so that's about the detailed design report that the program is capable of providing. It generates a separate design result for the basement walls. So that is getting generated right now. Okay. So that's about the detailed output. When it comes to drawings, we can get the floor plans like this. I'll show the foundation plan in this way. This is the foundation plan, wherein you can see the mat foundation. You can see over here, this is the rebar arrangement results that the program has provided. You can look at the pile locations as well. It will be dash type. So if the location is somewhere else, you can get that information also. You can get the structural plans of centerline plans and floor plans of any location. That's the floor plan. Then we can also generate the rebar arrangements for beams, columns, walls, basement wall as well. So for example, beam, selecting a beam over here, you can actually get the bar bending schedule as well for the beam rebar detailing. The workspace that you see here can be used just like AutoCAD. So this is a rebar arrangement that we can see for the top, bottom with the splicings and development lens. And you can get over here the key plan, and you can see the sectional arrangements as well. So this is how it will show. And we also get the bar bending schedule, rebar quantity table. All right. And also we'll be able to generate the bill of material in the form of Excel sheet. So here I'll just create the result for RC members only, and I'll uncheck for the steel. So you can just uncheck all this and we can generate the Microsoft Excel file for the generation of a bill of material. We can get the results of the design in the form of tables as well using this RC section option. So this is the result for the basement wall. So basement wall design result is also provided by the program. Okay, so in the table format, we can get the reinforcement arrangement, which can be edited and rechecked with the codal provisions. You can even take this information into Excel sheets by right clicking. Okay, so right now we are getting the bill of quantity generated in the Excel file format. And let me get back to the presentation where I would also like to show about the reports. So these are the summary reports and detailed reports which we have already seen, wherein the subclause numbers were also provided with the formula and all. Now this is regarding the report maker, which I would like to show in the form of video, small video here. So you can actually create a template wherein you can provide the information of the inputs and outputs of your project. It's not necessary to get the entire bulky project report. Select the information that we want. Even you can select which all members you want to take the output of. You have full control on the font size, on the margins, and what all text information that you have to provide. By clicking on generate, the entire project report gets generated. You can choose which all images you want to include in your result or report. And if you have any modifications in the project, you can generate the entire project report easily and convert that project report into a Word file. So a Word file would be nicely generated for the project. So in future, if you have a new project, you can open your template. Basically, you can save your template, open it again, and directly generate the entire project report in a very less period of time. So that's about the high-tech output generated by the program. Okay, so let me go ahead to the Midas support services offered. So Midas offers solutions or in the form of videos on our website. Let me talk about some conclusions that we have seen today. We have seen that superstructure, substructure, and the foundation can be modeled in Midas engine for the analysis, design, drawings, and reports. There is CAD Tracer tool for modeling features. Node element type of modeling is also available. CAD-based editing tools are there. When it comes to applications, RC structures, irregular shaped columns, irregular roofs, railway subway stations, and in the steel structures, steel buildings, steel warehouse, stadium structures can be included. You can have general structures as well, like elevated water tanks and transmission towers. We saw that foundations and substructure design is available in Midas engine. And one-way, two-way type of slab design is available. Ribbed or waffle slabs are also applicable here. And flat slabs are also available in Midas engine for the analysis and design purpose. Report generation is available in the form of Word file. You get a summary report and you also get a detailed design report. So that's about a detailed design report, summary report, and a customized submission report as well. Submission report would not require probably the entire information of these designs. So you can actually just provide a summary result if the design is okay or not good with the reinforcement arrangement. When it comes to drawings, you can get the rebar arrangements, longitudinal rebar arrangements, as well as bar bending schedule for beams, columns, and you also get for basement walls and shear walls and slabs and mat foundations as well. And bill of material can be generated in the form of Excel sheet. So here it is generated with us, the Excel sheet result. You can see this is how it looks like, the section, the lengths, the concrete volume in meter cube, rebars in ton, formwork in meter square. You get separate result for the basement wall and the footing and the pile information. So how many number of piles are there and so on, what is the diameter and so on. So that's about the BOM of the basement that we can get from the bill of material generated by the program. So that's a bill of material generation. Now let's come to the launch price, the offer. Well, this is the special launch offer for engineers of Middle East region, wherein you can enjoy the benefits of the full version of Midas engine that includes the Midas drawing. It includes the software training and the upgrades for a single annual subscription price. So it will be an annual subscription price. The original price is 3,000 US dollars, but as a launch price, it has come to directly 50% off, 1,500. And there, again, there's a special launch offer wherein if you buy two, you get two. So you get 4 licenses at the price of just 2 licenses. You can also get Midas iCAD license subscription free based on these purchase. Midas iCAD is similar to AutoCAD. It's a drafting tool, a CAD drafting tool. And this launch offer is valid until 15th May 2020. Let me again tell you the training and technical supported will be supported free of cost. It is included in this package. This is an annual subscription based method. All right. Thank you everyone for attending. Please note that tomorrow also we are having another session on Midas engine for 3-bay industrial steel warehouse structure. You will be given the links to join this session for tomorrow by today itself. So you shall be receiving the email for joining tomorrow's session, which will be from 3 p.m. to 2 p.m. as per UAE time, and so on, as you can see in your invitation cards, emails. All right. Thank you again, everyone, for attending this session. We shall be answering to the rest of the queries by email as the time is exceeded. Okay. So thank you, everyone, again, and have a great day and stay safe. Bye bye.